Hi, I'm Preston DeGuys, and this is part 2 of the NetWorker Architecture Basics series. This video collection is designed to help you understand the fundamentals of a networker operational architecture, and it's designed for people who need a bit of an introduction into the various aspects of a networker solution. Now, I'm assuming you've watched and understood the concepts introduced in part 1 before you watch this video. Keep in mind, this video series isn't meant to be a replacement to formal networker training, but it can be used to give you a bit of a head start with this awesome backup and recovery solution. In part 1, I covered off zones and hosts. In this part, I'm going to cover off operation types and targets. This is a short section, but I really want to briefly mention the different types of operations NetWorker can perform within your environment. This will help set the scene for later discussions. Now, in this section, I'm not going to cover all of the different operations, including maintenance operations that you may perform against backup targets or backups that have expired. I'll cover those off later, but let's just start with the essential ones. Now, as you'd expect, a backup operation in NetWorker is where NetWorker copies data from a source client to a data destination or target. In the next section, I'll cover off what those targets can be, but for now, this explanation is actually sufficient. Of course, once a backup is done, you need a way to protect your backups. After all, a backup should never be a single source of failure, so you'll want to replicate or copy your backups. In NetWorker, this is referred to as cloning. One of the most common reasons to perform cloning is to generate your offsite copy. Back in the days when tapes ruled the data center, you'd clone your backup tapes to your off-site tapes and then have a media handling company pick them up and drive them away. But cloning can also refer to more modern techniques as well, such as deduplicated replication between two data domains. While we consider a clone operation to be a copy, it's not generating the first copy. Internally, NetWorker keeps track of the number of copies there are of each specific backup that we've done, and that means the backup is considered to be a copy in itself. We'll go into that in more detail later on. Now, a staging operation is a very special cloning operation. In fact, if you watch NetWorker performing a staging operation, you'll see it start by calling it a cloning operation. Staging is what NetWorker does when you tell it to move backup copies from one target to another. Staging is where the backup is cloned, and then once that's finished successfully, the source copy that we read from can be deleted. You might do this because you want to move backups from disk to tape, or between disk backup devices if the source is filling up. There is one other type of operation I'll mention, but we're not going to spend a lot of time on in these videos, and that's the archive operation. An archive in NetWorker is a special backup that's written without an expiration date. That is, you're telling NetWorker you expect to basically keep this backup forever, so to speak. If you really want to, you can even tell NetWorker to delete the source data after the backup has been performed successfully. It's important though to know if you use the delete option, this is a true archive operation. There is no stubbing performed at all. Archive backups used to be very popular with medical, design and engineering companies, to name a few, where entire projects would be moved off disk to keep permanently, and if you ever wanted to do a restore, you'd more than likely want to recover the entire archive. So there are our different operation types. Now it's time to look at targets. At this point, I'm going to define a target as something that a NetWorker backup is written to. There are a few configuration concepts around backup targets that you need to know in order to get underway in a NetWorker configuration. When we think of a target in NetWorker, we don't just point NetWorker at a directory or tape and tell it back up to this location. Because NetWorker understands there can be a lot of different requirements around where your backups land and how they're processed, we need a bit more configuration than that. NetWorker has a particular way of getting to a point where you can write a backup. This lets you organize and separate your backups more easily, and based on its legacy of tape-based backup days, differentiates between the piece of hardware that you write a backup to and the media that's in that piece of hardware to hold the backup. So when we talk about targets, we need to be aware of three different things. These are volumes, devices, and pools. So let's evaluate those in detail. The actual target in NetWorker that your backups, clones, or archives will be written to is called a volume. A volume is going to be any atomic unit of media. Back in the days of tape-only backups, each tape would be treated as a volume. These days, with disk-based backup devices, which are either conventional storage or data domain deduplication storage, your volume will end up being a directory on the storage system. There'll be directories created underneath, of course, but you can think of the root of that folder structure as being the start of a disk-based backup volume. Now, you can't just pop a chunk of media in front of NetWorker and have it write a backup to it. Since NetWorker is about protecting data, you have to tell it that the media can be written to, and you do that via a label operation. A label operation writes volume header information to the media, which NetWorker also stores in one of its databases, the media database. We'll cover that off later. Once the volume header is written, NetWorker can identify the unit of media as being a usable volume, and it will allow you to write data to it. So whenever we write a backup, clone, or archive, we write it to a volume. NetWorker also has the concept of unmounting and mounting media, but I'll come to that in the next slide. A NetWorker device is a storage medium that can be used to access a volume for reading, writing, and so on. NetWorker sends data to a device service assigned to that device, and the service handles writing the data to the media within the device. This lets NetWorker add support for new types of backup technology more easily, and NetWorker has certainly supported a lot of different device types over the years. Common device types that you may run into will include the data domain device type, conventional disk, which NetWorker refers to as an advanced file type device, and the various tape formats such as LTO8, LTO7, and so on. Do you remember in the previous slide how I said you had to label media before you could write to it? Well, there's a bit more to that. NetWorker was built around the notion of removable media, such as tape. Not all tape drives or drivers tell the operating system when a tape has been loaded, so NetWorker has the concept of mounting and unmounting. Using tape as an example, once you put a previously labeled tape in the drive, you could mount it, which basically meant that NetWorker would read the volume label from the front of the tape. Likewise, if you wanted to eject it, you'd tell NetWorker to unmount it before you proceeded with the eject function. That combined unmount and eject prevented you from trying to eject a tape that was already in use. It also meant you could unmount a tape from your desk, then walk down to the server room and eject it from the drive without concern that another backup job would start using it. Once you've unmounted the tape, NetWorker won't attempt to read from it or write to it until you mount it again. Now, when we're doing disk-based backup, you still mount the volume, but that means just getting NetWorker to check for a volume header file. This is handy to know because if you temporarily want to stop NetWorker from using a disk-based backup volume, you can temporarily unmount it. It doesn't do anything to the volume other than to have NetWorker assume that there's nothing at that device that can be accessed. Don't worry though, your data is still safe there in that state, waiting for the volume to be mounted again. We've talked about volumes and devices, so what are pools? Well, a pool is a collection of one or more volumes that have the same attributes. One attribute can be differentiating between volumes that store backups, volumes that store clones, or volumes that store archives. In actual fact, there's a bit more differentiation that happens there, but we'll cover that off at another time. But there's more to pools than just whether they hold backups, clones, or archives. You can use pools for physically separating volumes. For instance, you might create a pool for your on-site backups and another for your off-site backups. but you might also want to separate out other backups. For instance, you might send day-to-day backups to regular data domain type devices and compliance data to data domain compliance devices where retention lock is enabled. By having separate pools, you avoid sending data that doesn't need to be retention locked to a device that will apply retention lock, and vice versa. If you're still using tape, pools can be handy to differentiate between retention times. You might create an on-site daily, on-site monthly, and on-site yearly pool, then off-site daily, off-site monthly, and off-site yearly pools. That lets you make sure that you don't write daily backup data to tapes you intend to keep for, say, 7 years. So let's piece these different targets together. A volume is something that you store your backup data on. It's a piece of media, like a tape or a disk-based backup device. Your device is a piece of hardware that lets you transfer backups, such as writing the backups in the first place. And finally, a pool is a collection of volumes that have similar properties or attributes. So in the previous video, I covered zones and hosts. And in this video, I've covered operations and targets. Let's look at how all 4 of these concepts piece together. Let's walk through how a backup works with NetWorker. In a later video, we'll flesh out some of the details. Now, it all starts with the NetWorker server. And of course, you need a client that you want to back up. The server tells the client to do a backup, and that's when the storage node comes in. The client talks to the storage node. Depending on the configuration, it'll either send its data to the storage node to be written to basic storage like tape, or if we've got smarter deduplicating storage available, it'll send its data directly to a data domain. This is called a client direct backup because the data flows directly from the client to the end storage. Whatever happens here, we know that we're writing backup to a volume which is accessed via device, and the volume is part of a pool of media. When the backup completes, the client sends metadata associated with the backup back to the backup server, the NetWorker server. And as backups complete, NetWorker will coordinate getting them cloned or replicated. And you can see everything that's going on through a variety of interfaces, including the Networker Management Console, or NMC. That's it for part 2. Thanks for watching. In part 3, I'll introduce some details around how NetWorker refers to backups and the various types of information it stores within its databases. Don't forget, you can check out the blog for more details. And if you're after a comprehensive understanding of data protection, be sure to look for the 2nd edition of Data Protection, Ensuring Data Availability from your favourite bookseller.